Ever wonder if that trendy foam concrete can really hold up? We put it through the ultimate gauntlet against traditional concrete. Prepare to see shocking results that will make you rethink everything you thought you knew about building materials. Foam concrete is far from being a simple styrofoam. Its strength comes from its unique porous microstructure. A large number of closed micro bubbles are formed in the cement matrix by physical or chemical foaming techniques. These bubbles reduce weight, but the overall structural integrity of the material remains high. Its compressive strength range is wide and can be adjusted according to requirements. Low-density models. Dry density, 250 to 300 kilograms per cubic meter, have a compressive strength of about 0.2 to 0.33 megapascals and are suitable for non-load-bearing fillings. Medium to high-density models. Dry density, 500 to 700 kilograms per cubic meter, have compressive strengths of up to 27 MPa. Even higher when reinforced by fibers. The addition of polypropylene fibers or web fibers, for example, results in a significant increase in compressive and tensile strengths, as well as in modulus of elasticity and residual stress. Strength comparison with conventional concrete and other lightweight materials. Foam concrete has excellent specific strength ratio of strength to density performance. Studies have shown that polystyrene foam particle concrete has a specific strength of up to 5.09 x 10 square meters s, which is superior to many conventional lightweight aggregates. Foam concrete is 30 to 40% lighter than conventional reinforced concrete, but structural requirements can be achieved by optimizing the proportioning, for example, using fiber reinforcement. For example, the reinforced foam concrete roof panels used by the Harbin Meter and Instrument Factory as early as the 20th century had a load capacity of more than 30 kilograms per square centime tray, about 0.3 megapascals, while weighing 40% less. Removing durability concerns. Longevity and resilience of foam concrete. Foam concrete is far more durable, especially in terms of moisture resistance, fire resistance, and long-term adaptability. 1. Moisture and freeze, thaw resistance. Adding foam stabilizers, such as animal protein, can enhance foam stability and reduce water absorption. Research shows that the optimized foam concrete water absorption can be controlled at 6.6% to 8.3%. The micro bubbles generated by the air entraining agent act as built-in shock absorbers, significantly improving freeze, thaw resistance in wet and dry cycling tests. Even if there is initial damage, the strength deterioration tend to be non-linear and slow, slowing down after 400,000 cycles. 2. Fire and thermal insulation properties. Foam concrete is a class I non-combustible material with a fire resistance limit of more than 1,000 degrees Celsius. For example, a 20 centimeters thick wall can resist high temperatures for more than 2 hours in a fire test. Excellent thermal insulation performance. Thermal conductivity is only 0.09 to 0.17 W per mK. The thermal insulation effect of 20 centimeters thick external wall is equivalent to that of 49 centimeters clay brick wall, and the long-term use can save energy by 30% to 40%. Dispelling the myth of expensive and complex cost and construction. Efficiency of foam concrete. The actual cost of foam concrete was lower than expected, and the construction was easy and efficient. Cost analysis. As an example of a wall project. Material and labor. The cast-in-place technology. realizes the integration of foaming, mixing, and conveying, with vertical conveying up to 120 meters and horizontal conveying up to 800 meters, which significantly reduces labor and machinery costs. The overall project cost can be reduced by about 30% compared with the traditional method. Energy savings payoff. Insulation reduces heating, cooling energy consumption, and saves energy costs in the long run. Studies have shown that buildings with foam concrete have energy savings of over 75%. Construction, convenience, self-leveling, and self-compacting properties. No need for vibration. Can fill complex spaces. Efficient operation. 25 cubic meters are poured per hour, which is equivalent to completing nearly 2,000 square meters of wall per day. At 120毫米 thickness. The non-demolition foam work technology directly realizes a flat surface and eliminates the plastering process, reduces waste and shortens construction time. Precise mechanized production reduces material waste and overall construction time is shortened by 50% 到 70%. The Lishui project was opened to traffic early through rapid backfilling, debunking the not green fallacy. The sustainability advantages of foam concrete. Foam concrete is ideal for green building, and its environmental friend lenses is reflected in its full life cycle. Raw materials and production processes. Industrial wastes, for example, fly ash, slag can be used as cementitious materials, reducing the consumption of natural resources. For example, the dry density of slag-based foamed concrete can be as low as 250 kilograms per cubic meter. Low carbon emission. Production energy consumption is 30% lower than traditional concrete and can be further reduced by optimizing the proportion. Energy efficiency contribution. The excellent insulation properties directly reduce the energy consumption of building operations. Calculations show that foam concrete buildings can be more than 75% more energy efficient than ordinary buildings, corresponding to a reduction in carbon emissions. Recycling and future potential. The material can be recycled and reused. For example, after crushing as a lightweight aggregate, foam concrete is now used in innovative technologies, such as self-healing concrete 3D printing, which is driving the construction industry towards the goal of zero waste.